This video is a quick overview of the interface of TxtShuffle, both shuffle by power and shuffle by temperature. The shuffle by power also includes the temperature option, however, it does not include different increment. Still, these two programs can be used for one-channel measurements for preliminary data processing to combine a lot of files into one table. So here, like this, I will go through the most important things and I will focus on shuffle by power most because, as you can see, a lot of things they have similar. The only thing that shuffle by power does not have is an increment, because in case of shuffle by power, the increment in all measurement set is 1. And there are a lot of different options, however, most of them are redundant and were used in the previous versions or were added for testing or were added temporarily, but were not deleted. So most important things are the pass-to file, which is based on the presentation one, the data output and naming rules. You have different prefix and suffixes for power-dependent or temperature-dependent measurements. Then you have information about the counter. Is it the temperature or is it the rotation? The first file, the number of files, the number of rows program gives to you automatically. You should not change it yourself. In case of power measurements, you have different options. Firstly, if you use last power measurement as reference, then you need to just put the reference power in milliwatts. Here you also have the last measurement power coefficient. So, for example, if the last measurement power was measured that was with a voltage twice less, then you can put coefficient. However, as I said, these options are mostly redundant, that usually you use either reference power for last measurement, or if this checked, you use voltage as a reference. For example, if my 200 millivolts means 200 milliwatts means 5 volts, I use voltage as reference. If my 200 milliwatts means last measurement, I just check this. Additionally, you can use influence. However, I explain it more in the power routine. Here I want to explain some details that I would not cover into power or temperature routine. For example, how this align, what is the difference between percentage of R versus align to certain percentage is. Get percentage of R, it calibrates the signal based on the voltage, the input voltage, and the input voltage that the photodetector measures inside of the file, and it compares to the given some values that, for example, let's say I recorded 4 volts using the filter that gives me 10% transmittance, 0.1. It means that 100% is 40 volts, so all the signal will be recalculated using this percentage of R. So if you use percentage of R, it is recommended to not do delta R by R, to not subtract, to not divide, to get percentage of R directly, absolute values calibrated. However, if you use delta R by R, you have another option, is to align to certain percentage. This option is useful when I know that my equilibrium reflectivity, for example, and if I'm speaking about my reflectivity data as input here, is if it's 10%, so I can calculate delta R by R, but then I align my equilibrium level to 0.1, because delta R by R gets me relative change, and as long as I know equilibrium value, I get absolute change. So this is the difference between delta R and align to certain percentage. Another important difference is all of these different options here. Shift Y by value, align to first measurement, and align to 0 to certain value. Shift Y by a certain value is used when while setting up the boxcar, you put your 0 into negative value to use the entire range of your analog digital converter from -10 to 10, let's say, and you put your 0 at, let's say, -8. So I have to shift Y by 8 to make sure that it's at 0. Align 0 value is redundant, it has kind of the same idea as the shift Y, but here you will align all of your initial equilibrium values to some voltage. Align 0 by first measurement ensures, especially for power-dependent measurement, that the entire set of data starts with the same value. And important to note, it does not multiply, it subtracts the value. So it is not to renormalize data, but is to subtract some parasitic, for example, when you have pump scattered light, that with increased pump, you increase signal. It's not pre-excitation, you increase equilibrium signal. You have to align to subtract that additional pump signal that you get. And that's about this options. Another options explained into the details in the power or temperature routines. Additionally, here the check data, get marks, get last voltage measurements. Sometimes it's useful to get the preliminary check of the data. These buttons were created for test of the program working. They were not supposed to stay here till this version. However, they're still here for some kind of debugging. Additionally, there are in the save file, while both routines use regression equidistant check mark should be there. Equidistant regression is the standard. You can save file without regression. You can save file average, and you can save file regression and average, which is, in my opinion, is best to save new file just regression. However, you can also do average option, which is you average and you use trailing average, you average nearest points, and you can repeat the process to make your signal smoother. Still, I would say it does not affect signal as good as, for example, filtering that can be done in the origin or in the optional program that I'm developing. And save file, the biggest disadvantage of this option that the X column is not the same, and for that reason it's not convenient to use, and it's all the first version of the programs were using just file. They were added for test purposes and stayed to the last version. Lastly, there are save peak and power, or save peak from average regress data. These features right now, they can be obtained better using min-max search or cross sections. So this functionality was implemented into the separate program.